we're going to do some programming. If you're watching this on YouTube, there should be a link to part 1 somewhere where we talk about what we are doing here, the ideas behind it. If you're watching live and you just tuned in and you don't know what's going on, then that's Twitch for you. You'll be able to go back and watch the file later on, or you can look on YouTube later. So we want to make a thing using metaprogramming that will produce SOA versions of our good old American apple pie AOS data structures, right? So an example, so I've imported math here in our mostly empty file. And math defines some things, but some of those things are the vectors that we use, right? I'm actually not going to do this yet because I forgot about this stuff. So for convenience of using these data structures, we have like, these are like little swizzles, right? So you could get the X, Y, or Y, Z, or you could refer to things by index. And if we want our SOA thing to ignore all these things correctly, that's like an extra complication. I don't want to think about that yet. I just want to do the good old basic thing first. We'll get that working, and then we can get it working with like stuff like this, right? So what place is it's a different way of doing a union. It's like the go-to of making unions. So what this says is this goes at the same memory address as what X does, right? And this goes at the same memory address as what Y does. And this just lets us do a typed way of getting those two coordinates, right? We don't get all the swizzles like you do in HLSL, but we get those. I don't know if I like this enough to leave it in. I assume this is something Ignacio did or something. It's interesting, but who knows? I mean, like, do we really want all these? Like, really? I don't know. I think this probably makes sense. But even that, like, you could just cast this to the other thing. I don't know. This is all, you know, when you let other people program, they do stuff that you wouldn't have done. That's the drawback. Okay, anyway, we're going to make a copy of vector 3 over here, and it's just going to be like that. They are the cheapest possible swizzles. It is true. Okay. I would have to, like, if I wanted to consider whether I wanted to keep this or not, I would have to just go review how it's being used and how effective is that, and is it something I could do a different way just as easily, or do you lose performance or whatever, right? You don't want to just like go, oh, I don't like it, delete it. Okay. So we want to make something that looks like this. I'm just going to type in what the output struct is, right? We want to make like an SOA vector 3. This is going to be an AOSOA. We're just going to go all the way, right? Well, I'm not sure. Let's just do regular SOA first, so we don't have to think about that much. This is going to be a struct, right? And there's going to be like n elements, right? So that's going to be an int. Let's just say it's 64-bit, whatever. And then we're going to have x is n float, right? Y is n float, and z is n float. The end. Very basic. And we just want to make a thing that transmutes this into this. And then we'll take it further. So how do we do that? Well, let's just say, I have a weird naming convention where I don't like putting acronyms in titles because I like to know what the capitalization convention is. I don't want to have to know if something is an acronym or not. So I usually do this, which looks dumb, but I like it better for various reasons. So we're going to do that. Okay, how do we do this? Well, I'm going to make a struct using the body text feature like we did yesterday. We'll say SOA. I'm just going to call it SOA. We might want a more general name later, right? Of some type T and some N. Well, okay, here's the thing. Yeah, no, it's fine. So body text means that the code in here just generates a string that becomes the struct body, right? It's like not the struct body itself. Although actually I'm getting ahead of myself. Like the thing that we did yesterday was first we just wrote plain old code that generated this. So let's do that actually. Let's just write some code in main that makes this string, and then we'll just put it in there when we're done, because I like doing things that way. So let's just say, for example, T is vector 3, right? We have first class types in this language. We're defining T just to be an alias for the type vector 3. And the reason I'm doing that is just so that the code that I write below is pluggable into here. I'm going to say N is 16, because why not, right? So what do we do? I'm going to say builder is a string builder, right? Because strings and string building are different in this language, and that's why you can use strings without fear of slowing your program down tremendously. So I'm going to defer free buffers builder. I'm going to say, I'm going to do some stuff, and then I'm going to say S is builder to string. Forgot to take the address up there, right? And I'm going to say print result is, put a new line, comma S. All right. So what is in the string builder? Well, we say info is type info of T. And we'll say incomplete, ensure T is a struct. We did that yesterday. We could actually just go copy that code if we want. We're not going to worry about it yet. We just want to make it work. So for info.members, well, every member has a name and a type. And I actually wonder, I probably have a routine somewhere to print types, but I don't know where it is. We're going to look for that in a second. But certainly we can print the name, right? So we could say, actually, we don't really need to know N right now, because we're just going to say N in the string. So we're just going to say print to builder. Let's not indent, whatever. Name, colon, N, and then whatever the type is, which we don't know yet. I'm just going to leave it like this for a second. It.name, right? So it is the member. We're implicitly using the name from the for loop. And then let's just do that. Ship it. We basically did everything. Okay, hold on. I forgot to say struct here. That's what's going on. It thought this was a function body or a function header, and there's no $signs because I didn't say struct. Okay. Redeclaration of vector 3 because we're still importing math. Get rid of that. I want my simple vector 3. Okay, great. SOA. There we go. Result is x is n, y is n, z is n. So we have to put the type. We could just say float, and that would work for now. But let's... okay. So for basic types... oh, print type to builder. That takes a type info. How great. How great. Print type to builder. Info or it dot type, right? And then print to builder semicolon new line. All right. There we go. Float is an alias for float 32. I don't think we actually preserve enough information to know that I just typed float instead of float 32. That's why this is float and this is float 32. But it's fine. If we get grumpy about this 32, we could remove it later. But the point is, this is a perfectly good body for a struct. Okay? Well, now what? Let's just translate this, or not translate, but move it, right? So they're going to do all this, and then we're just going to return s. All right. So now we should hopefully be able to compile. Nope. Oh, right. Okay. So we had this problem yesterday where we couldn't do this. And in the middle of the stream, I was like, I don't know why we can't do this. I thought about since then why. And here's why. So body text and modify directive used to be the same thing. And in a modify directive, t can't be constant because you need to be allowed to assign it to other things. That's the whole point. I since then actually broke body text to be a little bit of a different thing from modify, but I didn't change the code. So like this is not marked as constant as far as body text knows. So we can't like do this, which is unfortunate. But we should trivially be able to change the compiler to work this way later. I just don't want to go into fixing compiler stuff right now. For body text, t should be constant, but isn't because of body text's history as syntactic sugar on modify, which it actually still probably is. But whatever, we're not going to do that. We're going to say info is cast type info struct of t and do that there. And that this cast doesn't care if it's constant. Okay, undeclared identifier s. Oh, down here, because we're still trying to print the result. Let's not do that. Okay, so now we don't do anything because we're not ever instantiating this. So let's do this, right? So let's say s is, or not s, well, because we called s the string. This is not a string. Let's say SOA vector, that's a long name, is SOA of n, or of vector 3, 16, right? Let's call this SOA 16, right? And then print well, our print function doesn't print polymorphic structs. So, well, now what? Well, we could make it do that. But on the other hand, what we really care about is the operations, right? Let's just do this for a second. I was hoping that we could do it like yesterday where we just print the struct and it all comes out. But in this case, it doesn't. That's a weird. Why can't I do this? Oh, the caveat that I forgot to say is we're venturing into territory that we haven't really done that much of, which is one reason why we're doing it now. And so several things could happen. We could run into compiler bugs. We could run into me just being confused and forgetting how things work because I don't do it that often. All these things are possible, and we just work through it at this point. So I'm not sure why it wouldn't like me saying SOA16.x. Oh, no, okay. Duh, guys. It's because I assigned this to the type. This is not an, okay. My print should have worked. You know, remember when I was saying, oh, we don't print polymorphic structs? That's like obviously wrong because we did it yesterday. This is just me being confused and jumping to conclusions. You know the jump to conclusions, Matt, from Office Space? I did that. Okay, here we just assigned this to the type. And so it is, we don't print the whole type, that's true. I should go in and actually print the arguments in the print function. This is just saying this is a type, right? We want an instance of that, so we want to do this. And that's why this didn't work, is like we tried to say, what is the X of a type? And I mean, we could define that as the type of the X member. That just might get really confusing. But this was also confusing. Like, I think the goal should be to give people the best user experience when they make this a mistake, because it's a pretty easy mistake. So maybe this error message just has to get better. Although I could see a case for saying SOA16.x should be the type and a float. I don't know, man. Anyway, so now let's see. Great. When you actually program, then you have a program at the end. Okay, so SOA16.x is 16 float 32, so that's great. Let's just print the whole struct like God intended us to do. There we go. Any questions so far? Questions before we move on? Before we move on. So we can, you know, how do you know that this is really SOA? Well, let's just say, see, the thing is, we would like to very conveniently still think of this as an array of vectors, but we can't now because we made an SOA thing, right? So this is the part that gets annoying when you're programming it, right? It's like, so we want, if we want the first X, right? Let's say pointer 0 is SOA16 dot X of 0, right? And pointer 1, right? Well, it's pretty obvious that, let's cast this to pointer to U8 so we can do pointer math. we take the delta and print delta is whatever delta, right? So that's going to be obvious. It's 4 bytes. But it's clearly 4 bytes from this. And so the thing is, it's nice that we're able to automatically make, let's delete this because that was just an example, right? So really what we're dealing with is this and then this. So it's nice to be able to make an SOA version of this at a given stride. But once we've done that, we have to do this annoying thing still. But so far we have saved ourselves a little bit of annoyance, which is that we could change this struct. Like say I wanted to have a W, right? Well, I didn't have to change anything else, and now it has a W, right? So that's good. We've made a step. What if it wants to have an index? U64. Now it's got an index. Great. So that's all good. Part of the remaining question is like, how do we do this? And then especially, what do we do what can we do to make it easier to talk about and manipulate the elements in here, right? And one answer is, well, you could certainly provide an array subscript operator. I'm not saying this is the right thing because I haven't done it, but you could provide an array subscript operator on this that returns this, right? Oh, and to prove the point, actually, let me make a totally different struct before we go anywhere, right? This looks like a little bit more messy code than this output would have been. Why wouldn't I just do this by hand? And the answer is, this works on anything now, right? So you could have entity, right? We had our entity, and it'll have position is a vector 3. Now here's the thing. Our code so far is not going to put these positions. It's not going to strip the X, Y, and Z out of position. It's going to leave each position as an individual unit. That might be what you want sometimes, and it might not. So we might think about adding a recursive option here or something, you know. But we don't have that right now. So this is going to go in. We're going to have entity ID is a U64 or U32, right? Entity flags is a U64. And we had some other stuff, but we don't care, right? So SOA entity is SOA of entity 100 print. So this is where we start getting the win as well, is once we want to start doing this to multiple things, because we didn't, once this is in place, we can just apply it to anything, right? Can you access the recordings and or the beginning of these? Yes. This will be up on YouTube later. I think if you go to the Twitch video page right now, you could see earlier into this stream. I think that actually works. Somebody can give them the link. Use a metaprogram to change every instance of SOA16 sub n.x in code to something like SOA16.x sub n. You could do that right now, but that's annoying because then you require people to have a compile time metaprogram, which they might not want. It's also a very heavyweight operation. Now you have to decide, are you doing that operation before you're doing some other code transformation or after? And frankly, it takes time to search for that pattern in the code, and you'd prefer not to do that. But that is a thing that you could do. And I think, you know, from when I've talked to Casey, that's the sort of thing that he leans toward. I haven't talked to him about it in a while, so I don't know exactly. How do you convert to a linear array of floats to send to a vertex buffer? Well, you could just either make a different function, or actually this is a linear array of floats. It's just 3 arrays, but you could cast this to a float star. That would be fine. That would actually work. What would be a good way for recursive SOAing? You would just modify this to recurse down into members. It's a lot like what we did yesterday, right? So, or the day before, when we did, and you can go back if you didn't see that, we did a thing where we were making a command line argument parser, and we made it so that it supports arrays of arrays of arrays of whatever. And when we hit an array, we would just re-recurse into the handler, right? And you would do a similar thing here, but for structs. Wouldn't that have some namespacing problems? Yeah, it might. I mean, if you just pulled something out and it had the same name as something earlier up, then yes. So don't do that, right? Don't name things that way. I mean, really, like that's the right answer in this case. Like some people get all bent out of shape about how to handle that, but it's like, no, like this is a sort of thing that a programmer does when they should know what they're doing. You know, I mean, you could, to be fair, you could just rename it in here somewhere, but like, But isn't it 100 floats of x, then 100 of y instead of xyz, xyz, xyz? Yes, that was the whole point. If you, I guess you missed the early part of the stream. That is the whole point of what we're doing. If you wanted xyz, 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 then why didn't you just make an array of vector 3? That already you could do in every language. Okay, let's try this. Now we're venturing into the territory that, dude, I haven't even defined an array operator on anything in many months. So let's have fun with this. Operator, array brackets. How does this even work? Let me just make sure so I don't bite myself. Okay, so yeah, you take an int as the second argument and you return, I think, whatever you want. So operator array brackets of $T, which is an SOA. Have fun with that. And an int, right? And we're going to return T. Well, okay, let's not name this T, because we would be returning T.T, which looks like some kind of emoji. And we can't have that. So let's go S for SOA. These don't have to be one character emojis. Okay. So for now, we're just going to hard code this for vector 3, and then we'll generate it, right? Like, I think we would use, I think the best option is to use body text on this. Interesting. All right, let's just see. So let's comment out the entity thing, because we're going to hard code this for vector 3 right now, and I don't want any weird problems due to generating this or whatever. I probably wouldn't actually. Let's see. Okay, so what does this mean? We're going to say result is s.t uninitialized, right? Now, we actually know that this is vector 3, but we're pretending a little bit that we don't know. Okay, and then I'm just going to say result.x equals, oh, I need lowercase, too many, what should I call this variable? Array, or just SOA, lowercase SOA. Result.x is SOA.x sub I, right? Result.y, result.z. SOA dot, right? And then return result. Pretty simple. Let me just see if that compiles. It does. Okay. Well, if we let's say v is SOA 16 of 5, right? Print type of v is whatever. V equals whatever v. So we're going to print the type first, and then we're going to print the thing. Although, I guess since this is a struct, we'll print the type anyway. Whatever. Whatever, man. I don't know how to program. All right. So it is a vector 3, which means that we got s.t correctly, right? And then, well, it's all 0. And the reason why is because we didn't put things in. Okay. So let's initialize our SOA 16, right? Well, let's just say let's just make an n here for a second, n, and then we'll say for 0 to n minus 1, SOA 16.x, let's call this I, sub I equals casting that I to float, right? That's what the double X is going to do there. This isn't a variable. We'll probably change this syntax later. Double X is an auto cast operator that just casts the thing on the right to whatever it needs to be to match the thing on the left. This is a quick and dirty. I could type this. We'll just do that. Whatever. Whatever, man. Okay, so Y is going to be minus I, and Z is going to be 1 left shifted by I. All right? So then we'll have, whoops, I, Z. I hope someone in chat caught that. Yeah, someone did. Good. Good. Okay. So now we're initializing, and now when we take v sub 5, right, the x coordinate should be 5, y should be minus 5, z should be 32, I guess. I don't know. Yeah, 5 minus 5, 32. So we know that this works, okay? So this is already another good, convenient step. Like, hey, I have this thing, and I can go back to vector anytime that I want, right? So now, what do we do? Well, I would bet, so somebody said that someone did this in C++. I would bet this is a lot better than the C++ version, but who knows? I'm initializing it with SOA syntax still. That is correct. We could make a function that produces an SOA array given a non-SOA array. We could think about that. I'm not sure how worth it that is, but maybe. So now here's a thing that we can't currently do. You would like to say the opposite. You would like to say SOA 16 sub 5 equals V. We can't do this for several reasons. One is that, like, the way C++ does this is with references, and we don't want to do references. Because that complicates the type system tremendously. So typically, we might return a pointer in a case like this. The thing is, there's no like pointer to a vector, right? So you might do this by returning like a temporary object. If it was C++, you might return a temporary object that equals was overloaded on that you would then blah, 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 right? But again, my philosophy on all of that over time has been like, oh my God, dude. That gets really ugly really fast. Nobody understands what's going on. It's hard for the compiler to optimize into fast code, and it complicates the language and spends your complexity budget that you could have spent on something better. So I kind of don't really want to make this possible. I think if you want to do this for now, we would probably just say like set, you just use a function, right? Or whatever, which is mildly more inconvenient, but like, oh my God, it's a lot easier to understand. And like when you read this, you know that something is happening here. You know it's not just an assignment, right? So we could do something like this as well. But we're not ready to do anything like that yet, because the fact is that this is hard-coded, and we want to generate this and make it work on entity, right? And there are two ways that we could do it, and I'm going to try doing it a different way. I'm going to try doing it the less obvious way, or maybe the better way. I don't know. Okay, one way that I could do it is put a body text here, right? And instead of having this stuff, right, do the same loop that I did here. And do it here. Maybe we should just do that. But the other option is, in here, when we generate this string, we could also generate the string for the array subscript and just add it to the build, which I think is legal. I hope is legal. You know? So let's actually do it the body text way, and we'll see. I haven't done body text for functions in a long time, so maybe this will break. Who knows? Okay, so this is going to be kind of easy. So we're going to do the same thing here, right? We're going to do the same thing here. And then we're going to do the same thing here. We still haven't made our policy about do we skip some members, right? So if we do that, we're going to have to duplicate it if we keep doing things this way, right? And then we're just going to do this again, right? Okay, well, at the start and the end of this are always going to be the same. They're going to be this declaration of result and this return result, right? So we're going to go append to builder, return result, new line, all right? And before we do the members, we're going to append to builder, result s.t equals dash dash dash. And then just for every member, we're going to say print to builder, right? SOA dot percent sub I, or wait, the other way around. Result dot whatever is SOA dot whatever sub I semicolon new line, it dot name, because it's the same name in both cases. Why was that easy? And then this was harder. Oh, because we had this type. We had to print the type, and here we don't. Okay. I think that's it. I think that's our subscript operator. I might have screwed it up. Who knows? It might not work. Undeclared identifier T. Oh, right, because it's S. Wait. No, S is the SOA. I mean, it doesn't matter necessarily. Let's just make it the vector type. Because we could iterate over the SOA type and pick all the names. But since we iterate over the vector type here, let's make it the vector type here as well. Or whatever it is. The thing that's SOA'd. T is not, oh God. Okay. We're going to do this. So this is another interesting thing where Wait, is S a type info already? In body text? Oh, that's so, okay. These are like old decisions that were made years ago that I haven't like questioned. All right. Let's look at, this actually gave us, so I think in the pre-stream I was talking about this added strings file that contains the things that we output, and I wasn't sure where it was going. I guess we put it in .build now because that's cleaner to put all generated files in one place. We used to just dump them wherever you're running. All right. Okay. We don't work that hard to auto-generate everything, so this is not printing the type there. But this is actually just for this. This isn't for this. So we haven't flushed the file. I think we don't flush the file before we exit. So we're referring to line 16. We don't have 16 lines. So let's try to debug. I don't want to fix compiler stuff today. We're just going to try to debug this without that. But if we have to, we can go fix it. T is not a member of vector 3. All right, it is generated by this body text directive. So why do I think, like, this is the only .t, right? T is not a member of vector 3. It might actually be, I don't know. Why do we think T is a vector 3? Let's just print this is a great thing, is because this is just compile time code, we could like put print statements in there and they run. So info that we're getting in this case is SOA, right? It's not the vector. So why? Am I being dumb? Return value of the operator. Oh, wait. Why am I returning a... Oh, no, I am returning a string. No, that's right. T is not a member of vector 3. I assume that's referring to this line because that's the only place where we do a .t. Except for this, but it wouldn't be complaining about this, I don't think. You know what we could do? Just so I don't have to fix a compiler thing. Before we try to make this an operator, right? We can just go like func of this. Because it's the same thing, and we can... that's not really going to help. That's not going to help. I don't think. Let me just change this and make sure that that's the error message. Yes. So it doesn't like, but it's not saying not a member of vector. Now it's saying member of SOA.poly, which makes sense to me. So why did this, what? I don't know about what's going on here. It might be the error message is wrong somehow. Okay, let's go back to the SOA. T is the name of the type, right? Let's make sure, okay, let's make sure that we could do that down here. Whatever is SOA 16.t. Now that's not quite the same thing. Whatever 2 is type of SOA 16.t. Right, so this one is asking about the value, right? And this is the type. So, whoops, type of v. Because we commented out our v for a second. All right. So it's getting it right. So we might have a bug in body text for some reason. Or it could be a totally different issue. What do I try next? So that I don't have to go fix a compiler. Result.t equals SOA dot what? No, result.t is not a thing. You would print the generated code and see if the 4 is doing something unexpected. Yeah, normally we would have the generated code. I don't think we're doing anything unexpected, but we might as well take a look at that. Normally we would have the generated code, but I don't want to fix that compiler issue because that's a rat hole. It might be easy, it might take an hour. So let's just do this. Generate, well, let's paste this whole thing. And instead of body texting, we're just going to make the string, right? Generate same stuff. We just return the string, right? All right. So S is result s.t equals ... result. Oh, weird. Okay. Remember when I said it'll be fine to iterate over the struct? The type info for the struct contains the constant members as well. When someone was saying result.t, wait, how did you know that was happening? Did you just know, or did you see that somewhere? Well, I thought that was a suggestion. It was instead telling me what was wrong. That's magical. How did you know? Anyway, I'm not actually sure that this is the problem, but it probably is. It's probably just reporting the wrong line a little bit too. That's why the error message changed when I changed the variable. It's because this line is actually correct. We've got multiple problems. Problem 1, this string isn't getting flushed. Problem 2, it's reporting one line off. The problem was actually here. And that's why we got a different error message when I changed this. This is why we don't, yeah. That was the only other place a T could have been. All right, well, you guys are very smart, and I am fired. That is what happens there. Okay, well, let's fix this. There are several ways we could fix it. Let me just cast back to type. Okay, this is all a little bit weird, right? So the whole thing that started all of this is that inside the body text, S was not a type, it was a type info. And remember what I was saying before about the types not being constant? That was kind of why I gave people the type info. I don't know. These were all just really old decisions, right? So I guess I could cast back to type. I just don't know if I allow that, right? So let's say S2 is cast type info. Is that going to work? Unsupported. Okay, well, when worst comes to worst, you do this thing that is UB in C++. All right. So I think we'll have a stream later where we just go through and fix all these things. To fix, type needs to be constant in body text and not a type info. For clarity, probably all the types should not be. So the question is, in a modify directive, what do you do? Because you kind of want the type info. I don't know. We'll figure that out later. That's a separate stream. This is why I don't want to like rat hole on that, because I don't know exactly the right answer. But so going back to this, wait, did we finish that? Yeah. Okay. So going back to this, I'm just going to print that. So S2 is the type. So this is gross, but we're going to do it. We're going to do that. We're going to call this S, right? And then right, and then info is type info of s.t. Because I want to do the thing that I said, which is like, let's do the vector type. All right, what did I mess up now? Oh, yeah. Oh, God, right. This actually, this also should be legal. So what it's saying is, so that, you know, there's rules about like this is equivalent to what happens in C++ with like static members or whatever. And I think we may not correctly allow that in all cases. So like S is actually not constant right now because I'm like reading it from memory, right? But S.t is just a constant. And so I should be able to look it up. And I believe in most cases I am able to look it up. But here, I'm going to put this on the fix list as well. Fix. This doesn't work due to complaining that S is constant. Shouldn't it work? All right, well, you know, as I always say, the reason we're doing this is so that you guys don't run into these problems when we release the programming language, right? All of these will be fixed and beautiful. In fact, when I say some of these decisions about how data is passed into like modifying body text were made a long time ago, they were made when I didn't really know how the rest of the language was going to shape out. And so I couldn't really make good decisions about them back then, but now is a time when we can make good decisions about them. So it's time to go clean those up. Okay. How can I do this? Let's not do this. So our other option is to iterate over the struct members and skip the constants. All right. So now, whoops, I deleted this one. Result, colon, t.s equals dash dash dash, right? Okay. We had another to fix. One line off when reporting error in operator or whatever for some reason. Got to fix that. Okay. So we're going to take the type info of the struct, and then we're going to go to member. Oh, it's in preload? Oh, it's type info. It's in preload. I'm going to go to the struct member. And the member has a flag on it that tells you if it's constant, right? So I could have done this like 20 minutes ago, and I should have just done it, but whatever. If it dot flags and it dot flags dot constant continue, all right? Ta-da! Why didn't we just do it that way? Because we had to look for all the inconveniences. Okay. Great. So we're going to put this back into here. It's actually shorter than what we had for some reason. So we're putting that back into there and generate, let's delete, let's just be optimistic and comment this out and comment that out and comment these out. And get that, let's just compile that. Undeclared identifier T. What did I mess up? Where is there a T? Oh, it's s.t, not t.s. See, we were printing the string before, but, you know, we weren't actually compiling it, so mistakes like that wouldn't show up. Okay, so that's good. So now let's print the V things. Well, hey, people, we now have a working array subscript that is generalized. And to prove that, let's go do an entity. I don't want to initialize. Well, okay. So for we're just going to set the entity IDs, right? So we're going to say E is SOA entity sub 37. All right. Uh-oh. We got to cast this. Because by default, the iterator variable here is an integer, and we're trying to assign it to a U32, which isn't automatically casting because it's information loss. So there we go. We have the entity with entity ID 37. So we went through some effort, but at the end of it, we can now do SOA and subscript on anything, which is great. So we can delete that. We can delete this. We can go back to the added strings file, which hopefully flushed all the way. Yeah. So when we successfully, oh, right. Let's go back here and say, ensure added strings is flushed when an error is reported. So it's a little bit funny how we print these things out sometimes, but they're sufficient for debugging, right? So this is like the body of a, an array subscript operator, and then here's the string. We probably should write the parameters and stuff. I just didn't do that. Maybe I was too lazy. Maybe I didn't know how this was going to work out. Like for structs, we kind of write the parameters, but we don't totally do it. And this .poly thing is weird. Like this should all get cleaned up, right? So anyway, here's the function that was generated from the vector3. Here's the one that was generated from the entity. And you can step through those in the debugger and everything, right? There's no mystery magic to it. So that's very nice. Are there any questions about what we have been doing? This might be enough for the stream for tonight. I might want to go out and get some snacks and stuff. And then we could pick it up later. So there are several more things we could do. What could we do? Well, we could implement AOSOA, right? That would be interesting. We could, and then we're kind of in the realm of compiler features, right? So here's a thing. In addition to something like an operator brackets, I have thought about somehow implementing like an operator bracket dot, right? That meant something like this. So like if you said SOA 16 sub 17.x, that this, you could use operator bracket dot to turn that into SOA 16.x sub 17, right? Or whatever, however you wanted to store it. We couldn't have done that before because operator bracket dot would have had to be a macro because of this name element, right? And I think our macros are powerful enough now to do that. But I'm not sure. And so we would also want to do an investigation. Right? Is everything good if we make plain old whatever a macro, right? Or I don't know. You could imagine doing bracket dot where it wasn't an identifier that came in like X. Maybe it was something more like the integer offset, but then you would have to translate the integer offsets from one to another, and that's maybe annoying. So I don't know. But that is definitely a thing that we have thought about. Would that work if you did parentheses? Yeah, it wouldn't be super naive. It would apply to any case where you do subscript and then dot. Now, the reason I'm not super hyped about that is that that seems very specific just to the SOA use case. But the nice thing about it is it doesn't complicate the type system of the entire language, right? Because that makes combinatoric explosion of complexity with everything. It's just one feature that kind of lives on its own. And so I'd be more interested in doing that, right? But that's a possible thing. Yeah. Oh, another thing we could do, and maybe we'll do this right now, is what if we want to do an iterator over the SOA and just do a naive one, right? That iterates by vector 3. Like way back in the day, when we were doing our iterator demo, we did a naive iterator that just called bracket, and I think maybe we can do that. So let's go grab this, because I never remember all the parameters, and maybe that's a reason to shorten it. You know, I've been thinking, since we now have a way to substitute different macros, maybe we don't need to make reverse a standard thing in the language anymore. Like, if you want to reverse, maybe you just use a reverse iteration function. I don't know. I'm thinking about that. That would at least cut this down to 3 parameters, and 3 is like a lot nicer than 4, I think. Anyway, well, so this is not a bucket array. This is going to be an SOA, right? And then we're going to say for 0 to t dot n minus 1, right? That's how many things there are. And other than that, we're not going to have to do anything fancy because it's just a single dimensional loop. So we don't have to do anything weird with break or continue or anything. We'll just say insert body, right? We're going to export the it index with the backtick from here, and we're going to say it is array sub it index, right? I believe that should work. Right? So the big finale, if this works, is for SOA 16, print whatever index it is, colon, whatever, new line, and it, right? Something like that. Oh no! Oh, disaster. Okay, this is not good. That was going to be so awesome, dude. So there are some bugs in the for loop expansions that I'm not happy with, and this might be one of them. This might be one of them. I rewrote it after the demo, and like I didn't necessarily. I don't want to have to debug what this is, man. Okay, the very act of doing this for loop is causing the problem. Let me try that. I don't think that'll help. Nope. Well, oh, you think I left out an it index. You are correct. That is not the problem, but that is what I intended to do. I mean, I could try to debug this, but this could be a very, very hairy problem. Bummer. I wanted to do this awesome thing. So it might be that we just have a debugging stream on this particular feature. Because, you know, that would be really nice, again, to just be able to naively iterate over your SOA array just like this. It would be like, I mean, that's pretty great, right? Let's just name both of these. Right? That's not going to change anything. Yeah, my circular dependency diagrams are kind of useless lately, like something broke. So it just says that main can't compile for some reason. What if I put this into a different function? At this point, we're just trying to tweak around the potential. I don't think this is going to help either. Nope. So there is something about just having this for loop that is bugging us. Interesting. Let's just try to figure it out. So this is a macro expansion that does nothing, right? Oh, we took out our print. Let's put it back. I mean, we didn't take it out. We just moved it to a function that doesn't get called. So there we go. And this should print 0 with a default vector 3, right? Which is all zeros. That's not very useful, but that's what we gave it. So I wonder if the problem is that it's getting confused by a vanilla for loop. Let's try a while loop, like while it index is less than t dot n, we do a thing. We'll insert the body, right? All right. Well, whoops, redeclaration of it. All right. Well, we did it, team. I knew that there was a bug. Like it got to be a bummer debugging this stuff, so I like stopped for a while, and now it bit me live on stream. So this is just a compiler bug. So the nicer version of this function would be to use the for loop, but this is still pretty good, right? This is way better than you'd get away with in C++. So even though we have a list of compiler bugs, I am pretty happy with the output. And we have a subject for another stream. Can you even implement pointer equals true with modifications in the for loop by reassigning the vector in the macro? Wait, what? Reassigning the vector in the macro. I don't understand. Why would iterating by pointer? Oh, right. You mean we have a temporary value. We insert the, oh God. I have to do this. This is gross and stupid, but I have to do it, dude. Okay, we can't do it yet because we didn't write this set function, right? So remember before I was saying, that because we're not all C++ sized, we can't do, I guess I deleted it, but we can't do this, right? SOA 16, 5 equals V, right? But we can make like a set function that does that. So let's do that and we'll test it. And then we'll test this. And that could be entertaining. I mean, that's That's such an amusing suggestion that we have to do it. And I want to do it in time that I could then go to Whole Foods. So, okay. Let's do set. We want the array, we want the index, and we want the value is t.s, no, s.t, right? I should make this s and this s and this s. Just being consistent, right? Okay, so we're going to set this. I guess we do another body text with the opposite, right? Right? I don't think there's a cheaper way to do it. This Halloween stream is dope. Yes, it is. This is the most we're finding so many scary compiler bugs. It's a scary, scary Halloween. All right, let's just do this. We might be able to like compress this down. Whatever. Like, this is starting to become a lot of code, so it becomes tempting to consolidate the loops and all that, you know. Consolidate loops to shrink code. But for now, we're just going to be dumb because I want to go to Whole Foods and get snacks. So type info struct of s again. So we're going to do this, going to do that, and we're going to say print to builder. Oh, we have to body text up here. And we're going to print to builder just array dot whatever equals whatever semicolon new line, right? It dot name, it dot name. Pretty simple loop. Like by the time you're writing loops this simple, it's like, well, oh wait, no. Right, I didn't get it all. Array dot whatever sub index equals whatever. By the time you're writing loops this simple, this is mostly boilerplate. So we maybe could profitably have combined all of these. I don't know. I mean, we could like do the like whatever. Okay. Mismatching levels of indirection. Oh, I forgot the builder. Bob the builder. Okay, so we're going to print v, and then after set, so we're going to say w is v, w dot x equals 99, w dot y equals minus w dot y, w dot z equals w dot x plus w dot y. Set SOA 16.5 to w. And then we're going to read it back, right? Undeclared identifier x. What did I do wrong? Oh, equals. I hope somebody caught that. I'm sure someone did. All right. Okay, so we say this is v, and then after the set, okay. Wait, what? W dot x is supposed to be 99, but it isn't. But w dot y is minus w dot y. And w dot z is w dot x plus w dot y. So, what? Oh, v dot, I hope somebody caught that. Philip caught it right when I said that. Okay, here we go. after set. Okay, so our set function works. And when we iterate, we see that value in the middle of all these other nice patterns. And so now the suggestion was to do this frickin' thing. I'm gonna keep the neat for expansion before I muck it up with this absurdity. So we're gonna say if pointer else this. If it's by pointer, we're just gonna take the address, right? Okay. If pointer set array it index it, right? Okay. So we haven't actually used that yet, but we confirm that it still works. So now we're going to go by pointer and negate x and increment y or something, right? So, or no, negate z. Z is getting a big head, right? Or we'll make z 1 over z. Let's do that. Okay, so let's make this compact, right? Because we're going to do this twice. Let's do this. So we're going to do that. Well, let's just print it twice. So it's the same both times, but we're going to do this. For SOA 16 by pointer, it.z equals 1 over it.z. Uh-oh. This matching line is given, oh, set, right. Set wants a value. Didn't work. Why not? That was supposed to be magical. It says it's a pointer to vector 3. Okay, well, in the iterator, we'll just print. Oh, wow. Okay, so why aren't we setting that? Set should work right on Z because it worked right there. So what is going wrong? I mean, if I incremented the index incorrectly, I could see that going wrong. But this is the same index that we do with the body. Oh, guys. Print that back. It is set is setting it, but somehow we're copying this array somewhere. So that is also something we're going to have to look into. I guess I'm not sure why that would happen. Hold on. That's the address of that. And then pre-for expansion is, yeah, these are different addresses. Are they the same as each other? No. Okay, I have bad news, bears. We are, wait, I should have 3 pre's because there's 4 pre's. Oh no, sorry, it's 4 inside 4 expansions. Okay, so E930, EAA8, EC90, I missed one. Oh no, this is an integer for loop. Duh. Okay, those are all different addresses. We have another compiler issue, which is that we're copying the frickin' array when we call the for macro for some reason, which we shouldn't be doing. Does for expansion take a pointer to an object or a copy of the object? So in principle, because it's a macro, it shouldn't matter. It's an interesting question whether you want to let people... It's an open question, like what you want the semantics to be about, like... Maybe macros shouldn't be able to modify things and you should have to pass them by pointer or something. But in principle, I think that's not what it's supposed to be. I think it's supposed to be like it's supposed to be the stuff just goes into the scope, right? And you could modify it if you wanted to, and you're just supposed to exercise caution. Now, for some reason, so because these things just go into the scope, when this thing is getting copied, it must happen at the call site. So this is probably a relatively simple bug. Something in the compiler is just getting confused. And we want to fix that. Anyway, this is good. So we have a list of things to fix. Like none of them are that bad. I don't think I can do this, but let's see. We might have been able to do this. I mean, we'll be printing the wrong thing sometimes. Oh. Like the thing is, yeah, I would have to change some things in the body because you can't just subscript from an array pointer right now because that means a different thing. But the thing that it's the thing that it's complaining about is the actual call. Okay, so we're not, I could probably do a hack workaround for this like I did with other things, but we're going to do it right. We're going to fix the bugs for SOA 16 doesn't work by pointer because the array is getting copied for some reason. This is an important one to look up because if spurious copies are happening there, are they happening elsewhere, right? Are they just happening in macros, or are they happening for functions a lot of the time and slowing down the game? I don't know. I want that to be the number one that we look up. So next stream, I think we're going to debug these. And then stream after that, I think we do AOSOA, right? That'll be fun. And or look at this and try to maybe combine these into one loop and simplify it down, right? We found a bunch of bugs today, but it's good. None of them are too serious. And all of them just sort of come from, hey, I just haven't played in this exact space, which we should do before we release the compiler to people and tell them to do that. Taking a pointer to an element of an SOA array. How does that work? Am I? Where? Where am I taking a pointer to an element of an SOA array? Oh, here. No, this is this operator that we defined. So the way it works is this gets called, if that's what you mean. And okay, so when taking an address of something like that, I think something like this is illegal in C and older C++, maybe even newer C++. But here, if you have a return value from a function, which is not technically an L value, you're allowed to take the address and it'll just make it an L value, right? Is that a valid address to take? Yes. But anyway, we know that's not the thing causing the bug because when we print this address, it keeps changing. Which is not good. It means we're copying the data, probably, and unless I'm misconstruing. I've already misconstrued several problems. But thank you, people, for coming to my scary Halloween bug stream. It's been good times, and we'll do more. Any final questions, final on-topic questions? In the original syntax for SOA arrays, I remember liking how it was just an SOA token on the array declaration. Am I going to somehow put something like that back in? I don't think so. And the reason is that was something that I was excited about, and it sounds good. So what he's asking, let me just clarify for anybody who doesn't have any idea. There was a thing in the original demo where there were two ways of making things SOA. One way was, you know, if you had a vector 3, you could just say, I forget exactly, but you could say something like array is did it go like this? Something like that, right? But the other way you could do it is you could actually, when you define vector 3, you could say this, and then any array of vector 3 would automatically be SOA. And on the one hand, that sounded neat. On the other hand, there are potentially many problems with it. Like now a library that wants to make an array of your type suddenly has an SOA array and it didn't expect that, right? or library authors have to think about that all the time. Or even just your own program, like sometimes you just don't want that. And if you can't really control it, you were able to control it by saying AOS. Like you could do this and then do this, but like now that's an additional thing that you have to think about all the time. It just didn't seem super worth it to me in reality. It's one of those features that sounds super cool, but then you're like, I don't know, man, right? But we'll see. We'll see if this is actually something that people want to do and if it makes sense to make it work somehow. Where do the generated functions land in terms of file or global scope? Right now, we just put them at application scope, which is sort of like global scope, except your libraries don't see it. It's probably not the best thing to do that. We probably want to let you, well, okay. We probably at least want to make it be the same scope as the thing that generated it, you know, which is, we're not consistent about that right now. So if you generated it from file scope, it should stay in that file scope, you know, and it doesn't right now. Or maybe we want to let you specify. I don't know. We'll see.